All right. Good everybody. Masterman here again. So we are back to our physics classes, and one of my videos I did an introduction to simple harmonic motion, and I gave an example of the mass spring system, and I gave some basics on how to, evaluate the mass spring system. So in this video, we're talking about potential energy, kinetic energy, and mechanical energy of a mass spring system. Now, there's something you need to note. Now, in the absence of friction, the mechanical energy of a mass spring system is potential energy plus kinetic energy. As in the absence of friction, because in the presence of friction, some of the kinetic energy will be lost. But if friction is absent, the mechanical energy is equal to the sum of potential energy plus kinetic energy. Now, before we go into the formulas of the potential and kinetic and mechanical energy, something that we need to learn together. Let's talk about two important terminologies. There's what we call displacement, and there's what we call amplitude. Amplitude, which is represented, this is represented as x, and this is represented as a. Or in this video, I will represent displacement as x and amplitude a. So displacement is just any distance from the equilibrium position of the mass to a point that is not the maximum displacement. So while amplitude, on the other hand, is the maximum displacement, that's the highest position with which the mass moves from its equilibrium position to that new position. So we have a mass that was initially at equilibrium, and it was distorted by a force by a distance of 1 meter. Now, any distance from this position to, let's say, 0.9 is called the displacement, while this 1 meter where it ended or where it stopped is called the amplitude. So you can say that amplitude is maximum displacement. By the way, both the displacement and the amplitude are measured in meters. So something that you also need to know. So this is very important. So let's now talk about the formulas for the potential energy, kinetic energy, and mechanical energy of a mass spring system. Now let's talk about the potential energy of a mass spring system. By the way, it is also called work done in a mass spring system. Now, from our elementary physics, the common definition of work done is a work is said to be done when a force pushes an object to a particular distance, or can you just say work done is force times distance. That's in its magnitude form. That's when a force pushes an object to a particular distance, work is said to be done. Now, this formula is only true for constant force. Now, if the force is varying, as we see in a mass spring system, when I mean varying, that the mass is not constantly at rest or is not constantly experiencing distortion, either expansion or compression. That the forces are either increasing or decreasing. The work done is not force times distance, or rather, the work done of a mass spring system has a varying force, and as a result, the work done is just simply going to be 1 over 2 kx squared, where k here is the spring constant. By the way, this formula is gotten by integration of the force from 0 to a particular distance, and then if you want to integrate a particular function, you put the sign of integration, it makes it dx, and then you subtract the upper limit from lower limit, and you get this. So just to make our work easier for the students, so just know that the potential energy is half kx squared. K is the spring constant and X is the displacement. X is the displacement and PE represents potential energy. Represent potential energy. Now, for kinetic energy, well, the kinetic energy of any system doesn't change. It's the energy due to an object motion. And then the kinetic energy of a mass spring system still remains the standard formula, half mv squared, where m is the mass of the objects, or basically the angular mass. V is the velocity of the mass or the object, the mass, and then Ke represents kinetic energy as it is. So the next thing we'll concern ourselves with is the mechanical energy of a mass spring system. Well, mechanical energy is basically the total energy. And there's something you need to know. When you describe anything about mechanical in mass spring system, you have to use the maximum, because mechanical energy is the total. You have to use the maximum displacement. So basically, mechanical energy you have to do with amplitude. Something has to do with amplitude. So just to make our work very, very easy, the mechanical energy of a mass spring system is 1/2 Ka squared. K still remains the spring constant. Now Me represents mechanical energy, and then the A represents the amplitude. So please start on putting the important formulas in a square bracket so you can know the ones I need to note in your book. So feel free to note all of this down, and there's something I need to really explain in this video concerning the potential energy, mechanical energy, and the kinetic energy of the mass spring system. So the last thing we'll do in this video is talk about the acceleration of the mass spring system. By the way, a mass spring system has two types of acceleration: the ordinary acceleration and the maximum acceleration. So let's start with the ordinary acceleration, or most standardly acceleration at any displacement. Now, from Newton's law of motion, the second law of motion, the net force of a system is mass times acceleration. So in a mass spring system, the only force that is acting there is the distorting force. And recall from, if you don't understand that, you can check my previous video, that the restoring force of a mass spring system is equals to Kx. So the only force here is the restoring force for a mass spring system. So we can replace the net force with Ks. So we have that Kx is equals to Ma. Kx, is equals to Ma. So we have that A, which is the acceleration that we are interested in, is going to be Kx over M. So this is the formula for the acceleration at any point or at any displacement. A here described acceleration at any displacement. We have K here to represent spring constant, and then M here to represent the mass of the spring. Yeah, and not forgetting that X here represents the displacement. So now I want to bring man to your table, the viewers. What do you think will be the maximum acceleration? Let me give you a hint. Anything maximum has to do with amplitude. So What do you think? Feel free to drop the formulas of the maximum acceleration that you feel is correct. So, but in my next video, I will be describing the maximum acceleration of a mass spring system. But that's about it for this video. Thanks for watching. I remain mastermind of Mastermind Tutorial. I see. Like